Iran's Space Launch Vehicle, SLV, Q-100 was tested successfully by the Islamic Revolutionary Guard Corps, IRGC, in November 2022 and will be able to place satellites weighing 80 kilograms in an orbit 500 kilometers from the Earth's surface. However, this is not the end of the story, and Iran is developing a series of other space launch vehicles such as Q-105, Q-110 and Q-120 to either put much heavier payloads in the low Earth or a lighter satellite in geostationary orbit at an altitude of about 36,000 kilometers. What is Iran following by developing these SLVs, and how are these new SLVs staged, and what new motors will they potentially use? The short answer is that Iran intends a long, massive and persistent presence in space as one of its national security pillars. In order to be able to gather quasi-real-time and reliable intelligence, presence in space is key for any future defensive and offensive actions. For this purpose, SLVs are key to the Iranians. As you may know from my previous video, link in description, the Q-100 SLV is a 3-stage solid rocket that uses the Rafale engine as the first stage, the solid-fueled Salman engine as the second stage, and a smaller, as yet unidentified, but high-tech solid rocket engine as the third stage. The Rafale engine was a quantum leap in Iranian propulsion technology, because it uses a flexible nozzle for steering as well as carbon composite casing and motor, which is another technological advance that allows high-pressure chamber, and also provides weight savings compared to steel casing. To either reach much higher orbits such as geostationary orbit or to launch much heavier spy satellites into a Sun-Synchrous orbit, a powerful 4-stage rocket is necessary. Sun-Synchrous orbit is a particular kind of polar orbit. Satellites in polar orbits usually travel past Earth from north to south rather than from west to east, passing roughly over Earth's poles. Polar orbits are a type of low Earth orbit, as they are at low altitudes between 200 to 1,000 kilometers. Satellites in SSO, traveling over the polar regions, are synchronous with the Sun. This means they are synchronized to always be in the same fixed position relative to the Sun, meaning that the satellite always visits the same spot at the same local time, for example, passing the city of Tel Aviv every day at noon exactly. The satellite will always observe a point on the Earth as if constantly at the same time of the day, which serves a number of applications. For example, it means that those who use the satellite images can compare how somewhere changes over time. This is because, if you want to monitor an area by taking a series of images of a certain place across many days, weeks, months, or even years, then it would not be very helpful to compare somewhere at midnight and then at midday. You need to take each picture as similarly as the previous picture as possible. Often, satellites in SSO are synchronized so that they are in constant dawn or dusk. This is because by constantly riding a sunset or sunrise, they will never have the Sun at an angle where the Earth shadows them. In addition, every time a Sun-Synchrous satellite completes its orbit in approximately 90 minutes to 2 hours, it shifts slightly, allowing its sensors to capture scenes slightly off-path. This helps in acquiring more interesting data or images unobscured by shadows or cloud cover. Technically, the proficiency of securing successive images is known as temporal resolution, with higher such resolution equating to greater speed in returning to the same spot, as measured in days. Sun-Synchrous orbit is best suited to creating imagery for spy reconnaissance. A satellite in a Sun-Synchrous orbit would usually be at an altitude of between 600 to 800 kilometers. At 800 kilometers, it will be traveling at a speed of approximately 7.5 km per second. Currently, Iran has a spy satellite, NIR-2, with a resolution of about 10 meters, owned by the IRGC, in Sun-Synchrous orbit, and another satellite, Q-110, owned by the Iranian Space Agency, with a resolution of 1 meter, in a usual low Earth orbit. Q-110 can be used for both military and civilian purposes. It was built by the Russians and launched from Baikonur by a Soyuz rocket in August 2022 as part of a strategic partnership. However, Iran will not rely on Russian SLVs and expensive, in the range of $50 million or even more, Russian-built and politically sensitive spy satellites. According to the IRGC plan, in the next Persian New Year, which is about to begin in less than 2 months from now on, Iran will have the Q-105 SLV, which will be a 3-stage rocket with a new engine that will replace the Salman engine, the second-stage engine in Q-100. The new second-stage engine of Q-105 will be highly likely a smaller version of raw-phase solid-fueled motor. Therefore, Q-105 will be able to deliver a payload of more than 200 kilograms into low Earth orbit. About the Q-110 SLV, no information is available yet, and one can only speculate. But probably for Q-110, a new engine with a thrust of about 120 to 150 tons with a booster diameter of more than 1.7 meters and a raw-phase solid-fuel engine for the second stage will be used. The third stage of Q-110 might include the second-stage engine of Q-105. In this way, the IRGC will be able to place heavier satellites to the low Earth orbit using Q-110 SLV. Regarding Q-120, which will be a 4-stage satellite, according to the IRGC, a new engine with a diameter of 2 meters or slightly more is currently being developed and will be used as the first stage. It is most likely that the second stage of Q-120 is the first stage of Q-110. Further, the third stage can be either raw-phase motor or again unknown new engine, and the fourth stage might be the second stage engine of Q-105 or another engine. We will see. In fact, Q-120 will be the SLV that paves the way for Iran to finally enter the highly strategic geostationary orbit, a project that was started more than a decade ago by the late IRGC commander Hassan Tehrani Moghadam, who died in a mysterious and tragic explosion at a space propulsion development test site near Tehran in 2011. This video shows the first test of the first large booster stage of a 4-stage SLV, conducted 12 years ago. Development work on a first-stage Super Heavy with a diameter of more than 2 meters is still in progress. This 4-stage rocket will most likely be available in the next 2 to 3 years. Iran is currently capable of placing nanosatellites into the low orbit. However, using these series of SLVs such as Q-105, Q-110 and Q-120, Iran will soon be capable of delivering heavy spy satellites or multiple semi-heavy or mini-nano spy satellites in the low Earth orbit to create a constellation. This is extremely important since one way to enhance image resolution is through interlinked semi-heavy or small imaging satellite clusters at lower orbits, bringing the revisit times to hours rather than days. Iran is known to be showing increased interest in creating clusters of cheap imaging, navigation or communication micro or nano satellites. When interlinked, these can offer significant military capabilities to support the IRGC strategic activities in the region and beyond, such as tracking international shipping and targeting. Also, a satellite may only have 5 to 10 minutes to send data back before moving away from a ground station. The next possibility is the next ground station. However, the images are quite large. They are hundreds of megabytes or even a gigabyte per image, and they are taken frequently. The Americans have relay satellites in space that can transmit the images as soon as they are taken. Networking mini-satellites would allow for much more frequent data transmission from space to ground stations in Iran, enabling Iran to update its intelligence more quickly. This is undoubtedly critical and of immense importance to Iran, as intelligence is the backbone of defense and offense against any potential future attack on Iran by the West and Israel. With the consistent and resolute development of these SLV series, IRGC has shown its immense commitment to establish itself in space for a wide range of national security-related goals and activities. Thanks for watching and see you next time.